In order for a function to be linear, it only has to do one thing. The one thing a function has to do to be linear is have a constant rate of change. A constant rate of change means the function is linear. So when you get a question that says, is the function linear? It's asking, does it have a constant rate of change? If the answer is yes, it has a constant rate of change, it's linear. If the answer is no, it doesn't, it's not linear. So how do we tell? Well, from a table, what we have to do is actually quite a bit of subtraction and division. We have to go through every row on this table and make sure that the change in y over the change in x, which is rate of change, is the same. So let's look just at these first two rows here. And our y goes from -6 to -8. So we're going to do -8 minus -6. And then our x goes from 1 to 4. So we're going to do 4 minus 1. So -8 minus -6 is -2. And 4 minus 1 is 3. So we've got -2/3 as our rate of change between those two columns. Let's see if the rate of change is -2/3 through every pair of numbers. So let's look at the next two from from +4 to 7 and from -8 to -10. So we'll do -10 minus -8 over 7 minus 4. -10 minus -8 is -2 and 7 minus 4 is 3. So that one's also 2/3. So far so good, but it's got to be all of them. Let's go from 7 to 10 and -10 to -12. Same math. -12 minus -10 over 10 minus 7. -12 minus -10 is -2, and 10 minus 7 is 3. And if this last one is also 2/3, we're in business. So -14 minus -12 over 13 minus 10. -14 minus 12 is -2, and 13 minus 10 is 3. So the rate of change between every pair of coordinates is -2/3. So the answer is yes, this is linear because it has a constant rate of change of -2/3. Great. Okay, let's take a look at the next one. So our first 2 points go from 10 to 12 on the y and -3 to -1 on the x. So let's go ahead and do our math here. Our y is going to be 12 minus 10, and our x is going to be -1 minus -3. So 12 minus 10 is 2. -1 minus -3 is also 2. So that's a rate of change of 1 between the first two. Okay, let's look at our next pair. From -1 to 1 on the x and from 12 to 16 on the y. So the y's are going to be 16 minus 12, and the x's are going to be 1 minus -1. 16 minus 12 is 4. 1 minus -1 is 2. And 4 divided by 2 is 2. Not the same. I don't need to do any more. I don't need to do the next few pairs. To be linear, every pair has to have the same rate of change. These don't. Not linear because it does not have a constant rate of change. Does not have a constant rate of change. If even one pair of our x and y coordinate pairs is different, has a different rate of change, that means it is not linear. To be linear, it has to have a constant rate of change over the entire set of coordinates. Even one difference between them, not linear.